answer. What do you mean by random and what do you mean by grid? What do you understand by that? Please, you can speak. Are you able to hear me? Okay, maybe arranged and not arranged. So this one is the Narayan says this. Any other option of random and grid? Random search and grid search? Vivek? Okay, yes. And what about grid? Okay. So, okay. Grid is okay. So now, first thing what you need to understand is that we are trying to optimize our hyperparameters, okay? And Hello. I'm so sorry. I'm so sorry. There's again this internet problem. So, are you able to hear me? Can you hear me? Okay. Okay. Fine. 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 So, yes. Okay. So there's Chiranjeevi who is joining. Anupam, Pravesh, their internet problem. Okay, so as you already know that we were talking about optimization, right? And in optimization, if you can recall your first assignment also, we are trying to uh, optimize our parameters and hyperparameters, both of the things. And this is this you can say that this is one of the most trickiest part when you are building a machine learning, or I can say that when you are trying to build an AI based model, because what is there, it is very difficult to predict that what would be my best parameters, or what would be my best optimal parameters, that value I can set when I'm trying to build the model, at least in the first attempts. That means when you are building the model, you don't know what parameters to keep, how you can optimize those parameters so that you can get a good value. And this is why we are saying that you need to play with your hyperparameters to optimize them. Okay. And however, we say that because as the number of iterations are increasing, similarly at that particular time, that means your training time is also very large. Okay. So this thing we can say that when we have a large amount of data, so at that time, it becomes very difficult for us to optimize our parameters, what strategies to follow during optimization. Okay, so that's why we are talking about random search and grid search. I have written everything into the slides also, so that if you are not able to somehow hear my voice, you can still look into PPTs. Okay, so when we are talking about this neural network and we are talking about optimization, then we are trying to tune our parameters. Okay, because why we are saying that we are tuning our parameters, because tuning the parameters is the part of your deep learning. You require to optimize them. And if you are not optimizing your parameters well, if your parameters are not optimized nicely, then your training time would be more, or you rather I can say that it will take a lot of time for training. And that is where your model can reach a stage of local minima. So I'll tell you all these words. So you will reach, your model will reach that local minimum point, and that minimum point is known as your local minima. Okay, and thus you know that there are various type of training methods that are introduced into the machine learning, so that how we can train these models, how we can find the optimal parameters. So now we'll be talking about these two widely used techniques, which is your random search and your grid search, because these two techniques are very easy to implement also. Okay, so did you get this point, that why we need to optimize this? Why do we need to optimize our parameters, our hyperparameters? Are you clear about this? So please go to the slide once again. I've read it. So this is clear. Okay. So that is why we are talking about these two techniques, which is your random search and grid search. And then we'll see that how this random search is still better than your grid search. Okay. And now when I am talking about hyperparameters, so our goal, our motive is, while training the model, build model, is to find out the best configuration of hyperparameters, and that can provide us the best score on the matrix. So can you recall the all the kinds of score: accuracy score, precision, recall, and your test score, your validation score? So it is talking about all those scores. So when you are trying to build your model, you are trying to optimize your parameters, you are also trying to find out the best configuration. That means you are trying to find out the best metric for your model. Okay, and why but do you need the best metric? You need to understand that, because as a scientist, as a researcher, or I would say as an academician, okay, you would require that whatever model that you are trying to build, it is trying to have, it's built in less time, less money, less computation power. Okay, and that is why we are trying to do this optimization. We are trying to make it effective. So this effective hyperparameter, we are trying to make this hyperparameter search more effective than the one which we were doing earlier. So that is why we are trying to do this hyperparameter optimization. So can you go through this once again? Earlier I talked about this. Is this one okay? So now, what is our goal? Can anyone reply? Why? What we are trying to do in this? What is our objective? What is our objective? Yes, optimize. Optimize, that is why we are trying to find out the best configuration. Okay, so can anyone say what do you mean by best configuration? What do you mean by best configuration? Okay, so what happens when you buy a laptop or desktop? Then you look for best configuration for your laptop. And if, for example, earlier people used to buy assembled PC. So assembled PC was the one having all the best possible things. Okay, so this is your main goal, optimization. And why are you following this optimization process? Yes, because you want the best thing. Okay, and when you are trying to do this, you are trying to do this because as a researcher or as a hobbyist or as an academic mission, you are trying to apply different search strategies, and you are applying these search strategies during last steps of your development. Okay, so if you could have seen earlier, we tried doing manually, and then in the later stage, at the later stages of development, we are trying to apply these searching strategies so that we can see that what could be the best or what could be the improvements in our model. Okay, so you have already built a model, but then again you are applying these search strategies so that you can see that what more possible improvements in the model you could see after applying these kind of optimization technique. Okay, so I would say that rather that when you are trying to do a hyperparameter search, you are doing at a stage, and normally a stage which is during the last steps of your development. Okay, and where could you could apply? You could apply in a semi-automatic deep learning pipeline also, or rather we can say as fully automatic deep learning pipeline. So semi is something when your deep learning models are halfway, and fully is completely. Okay, so in the company they apply it like this. So now if you could see from slides 1 to 3 4, okay, in slide 1, in slide 2, in slide 3, in slide 4, everywhere I use this term hyperparameter. So if you could see here, I talked over this term here, I talked about this term over here, and here also I talked about this hyperparameter, and here here also I talked about this hyperparameters. Okay, so now it becomes important for us to study actually what are these hyperparameters. Okay, so what you need to understand is that hyperparameters are just like your variables. Okay, so you know variables, right? So hyperparameters are just like your variables that are determining your network structure. So for example, I would say like number of hidden units, number of hidden layers, and they are the variables which try to figure out that how your network is trained. So when I'm saying about training the network, so at that time I'm talking about learning rate, because this is the rate at which my network will learn. This is defined as a learning rate. Okay, so these are the variables that are trying to figure out your network structure, and that is also trying to figure out the learning rate. Okay, and when we are setting these hyperparameters, we are setting it before training. So that means before, when we are trying to optimize our weight and bias. So if I could show you this example, okay? So this is an example of a real neural network, okay? So can you see here, this is the input layer. This one is the hidden layer, L. This is again one hidden layer. This is again a hidden layer, and this is the output layer. So this one is the input layer, this one is the output layer, and these in middle, okay, they are the hidden layers. So when I am talking about this particular network, so what would be the hyperparameters in this case? The hyperparameters, I would say, is the learning rate. So can you recall, can you tell me an example where you have gone through this hyperparameter? Any answers? Okay. Any answers where you heard this word learning rate? Learning rate. Where you used it in your previous assignment? Okay. In MLP classifier, we use batch size in previous assignment, right? You use batch size, yes. While making model, Samrat, but not clear, Praveen, AdaBoost, in AdaBoost and Bidworth in back propagation. Okay, so when you were using your MLP classifier, then you use this hyperparameters, right? So at these are basically the learning rate. Can you recall the learning rate value that you set up to something? The batch size also, you put something that value, and then this dropout rate. So these are actually all known as hyperparameters. See, it is very important to understand these hyperparameters because they are the important part. They are the ones which are trying, they are just, can you imagine in kitchen, the gas that we have? Can you, do you, have you seen that? Have you cooked food in the kitchen? Yes, okay. Okay. So someday you need to make it for me also. Tea or coffee, something. You need to show your skills. So what happens when you open the gas? You press the knob. Okay? What do you say that knob with which you make your gas simmer, or you make it high, or you close switch off your gas? That button, or rather I would say it as a knob. Okay, so actually these hyperparameter, for example when I say to you, please make a coffee or make a tea. So what happens is, for making a coffee or a tea, you need to open those knobs, you need to on that. Similarly, these hyperparameters are the knobs. They are the knobs which can make your model, which can build your deep learning models. So if you don't have these knobs, if you don't on these knobs, if you don't set up these knobs, how you would be making a model? Okay, and if for example I say you something, cook rice, cook dal or any kind of dish, then you have to set up the knob, that when I need to give it more flame, when the flame should be low, because that is what you are trying to do the modeling with your food. You are trying to set up, you are making it in a controlled environment. Okay, so that is what is the concept of hyperparameters. Okay, for making you understand, you need to understand they are called as the knobs, which can which are very useful for building your models, or rather I would say deep learning models. So through them only you are doing these work, and they are the things which talks about your learning rate. So because you need to train your network, so if you are not able to train your network at a particular rate, so learning rate is defined as the rate of learning of a network, or I would say rate of training a network. Okay, so you need to set up these learning rate for training your network, and then you can see this number of hidden units. So either you want to have 200 hit. Can you recall this number of hidden neurons in your earlier assessment? Okay, so you were setting it. Can anyone what you were doing, you were setting that manually. Okay, so at that time you were setting those hidden neurons, you were making it 100, then 200, then 400, and then checking and then seeing all those values. But here you are doing it through random search. You are trying to do implement it through random search algorithm. So is this clear? If yes, please let me know. So if it is clear, then please let me know what it determines, what it tries to figure out or find. Find. Reply, please reply to this. Some of you are there. Samman, Ram, Rakesh. Okay. So, please reply. Structure of the network. So what do you mean by structure? What do you mean by structure? Reply. Saman, reply. What do you mean by structure? Model. Okay. So that means how many number of hidden neurons would be there? Okay. And yes. Okay. So, Vivek, can you tell me what is learning rate? Vivek, are you there? Vivek, Vivek, can you hear me? Okay, he's not able to hear me. Ram, can you tell me what is learning rate? Okay, so learning rate is actually not reducing loss. Learning rate is, for example, when the teacher is teaching in the class and some students, for example, say they have they can understand in a 1 hour lecture, for example, they understand 80% of the things. And if there is another student in the class and in 1 hour they understand 50% of the things, so we would say that that person is having a better learning rate of 80% as compared to the student who is having the learning rate of 50%. Okay, so rate in which you are getting trained, that is known as learning rate. There is again one more rate which is you could see here, which is known as your this dropout rate. What is this dropout rate? What do you mean by this dropout rate? So what do you mean by drop out? So drop out means that, for example, out of 10, 4 students dropped. Means 4 student doesn't make it. Yes. So dropout layer is when randomly you ignore neurons to go to the next layer. Yes. So actually you are trying to set these hyperparameters automatically through your search. And then there is again another word which is known as parameter. So one is hyperparameter we are saying, and another word we are saying as parameters. So parameters are your just this, the weights you could see here. Can you see this W1 written over here? This W2, W3, W4. So this W you could see, this is all the weights between the input layer and the hidden layer. This one is the weight of the second layer. This one is for the third layer, and this one is for the fourth layer. So here we are not calling it as a hyperparameter. We are calling it as a parameter, just as a parameter. So whenever you are trying to build a real model, you will have hyperparameters in your model. You will also have model parameters, and then you will have some kind of design. So for example, let's say this is a model design over here. This is a model design. So this model design says us various things. For example, it tells us that there are 3 hidden layers. So you can see it is written as hash hidden layers 3, or you can see it is written as optimizer SGD. So that means the optimizer that has been used here is stochastic gradient descent optimizer, or it tells us that the activation function that is being used here is ReLU, or it tells us that this is the dropout layer. So if you could see, this L4 says that this layer is the dropout layer. So this is tells about you the model designing. This is the design. So you will describe it as a design. So in your assessment, you have been given like the heading as designing of the neural network. So in that design, you write about all these. And then this is your hyperparameters. This is your model parameters. Okay. So is there any doubt in this? This is clear? Is this clear? Hyperparameter? Please let me know so that I can proceed further. Okay. Okay. Now, one thing that you also need to understand, that when we are trying to apply search methods, or when we are trying to apply the search technique, searching is not an easy task. Rather, I would say that searching is very expensive. Expensive in the terms of time, in terms of money, in terms of configuration, in terms of power. Okay. And when you are trying to apply searching, then you are searching for the best configuration. Okay. And we could also say that when there is modeling being done, then there is a challenge that searching, when you are searching for the hyperparameters, that can be a iterative process. So iterative process means that could be a repetitive process. Repetitive means again and again and again. So, and these are the 3 constraints. So what do you mean by constraints? Limiting factor, limitation, restriction. Yes. So these are the constraints. You can see the memory, the money, the processor. These are the constraints for this is a challenging task when you are doing a searching process, because under these things you have to do this. So that's why we say that searching is an expensive. Okay. So what should we do? So when we are trying this hyperparameter selection, okay, and this hyperparameter selection, this is the first step, okay, that we need to follow. And after doing this hyperparameter selection, after selecting our, I hope my voice is not so loud, is it? Then let me know. Then after this we go for training, okay. And so this is our step number one when we are selecting our hyperparameters with a promising configuration. So this promising configuration means with a optimal configuration, okay. And then we need to wait, and we have to wait until what? We have to wait, we have to then apply training, we have to run the training so that we can get the actual evaluation, okay. We need to train our model, and then after this we move to the third step, and third step is evaluating the performance. So evaluating the performance here means that we are trying to keep the track of the process of searching. So that means, for example, the teacher is evaluating your progress in your assignments. That means they are keeping the track of whatever work you are doing. So here in this case, we are saying that we are tracking the progress of searching. We are evaluating that performance. And then according to this, when this step is completed, we have evaluated the performance, we have kept the track, and then finally we track that process. So normally the four steps are there for searching. First thing, search your parameters, then train them. After training, evaluate your performance, and then track your progress. Okay, so these are the four steps. Okay, if you can recall, in the previous class, I talked about this talk strategies, and there I talked about this babysitting. Okay, so actually, this babysitting was the one which you applied before, okay, which was known as your trial and error. So this one was that. And then we are moving to this grid search and random search. So random search to आपको लगानी है. There's no other choice for you. You have to apply. And then those who further can go ahead can then apply this Bayesian optimization also. So these are all the four search strategies which are mainly used for the best configuration. Number one is your trial and error, second is your grid search, third is again the random search, fourth is the Bayesian optimization. So in Bayesian optimization, then there comes the probability also. And then you would also have heard of this a classifier which is known as naive Bayes classifier. So Bayesian optimization is mainly about that. So this is clear. The four search strategies, these four strategies, this one you have already done. You are supposed to apply this into your assignment, and then you need to compare this with this also in your assignment if you can. So this is your task for this assessment. And then further, after applying this random search, then you can go further ahead and apply this one, the Bayesian optimization. Of course, they are just the functions that are already made now, and you have to just import them into your codes. But again, you have to know that how all these algorithms work. So this one you have done, trial and error. The whole your first assessment, it talked about this only, the babysitting. So this is clear? Will we apply these search algorithms into our MLP classifier? Yes. So what you will be doing is you will be applying random search. So when you will be applying random search, you will get those best possible combinations. So for example, let me say that for your MLP classifier, you took learning rate something and your batch size was something, and what else was there? Few other hyperparameters were also there. So when you applied this random search, it will give you the best combination of all those parameters. So those parameter you will get like learning rate is equal to this much value, this batch size is equal to this. So this will be your MLP classifier value. So it has already searched the best values for your MLP classifier. This is what you have done. Vidwat, did you get it or not? Vidwat, आया समझ में? Earlier, Asta, optimization is the main purpose of your second assignment. The first assignment that you have done, you came out with certain parameters, combination of hyperparameters. Like if you can recall, you have tested your system many times. You have noted all those readings again and again. Can you recall that? With hidden neuron is equal to something, then you run, train, tested, you get some accuracy. Then you did it for again, you did that how many times you did 10, 10, 10, 10, around so many times you trained your model. But this second assessment says that you need to optimize now your model with one of these four, one of these three strategies. And then it will automatically give you your best hyperparameters. You don't need to set it now with the trial and error. Did you get it? Asta, are you getting it? Because this you need to understand, yes, why we are doing it, why we are, because earlier you can see that how many readings you have taken for a single experiment. So now you are not doing it again. You are just training your computer, searching out the best hyperparameters and saying that out of these, this one is the best combination. There is no need of trial and error. Okay. So this one, the trial and error. Let me show you with some assignment also, if I can. Let me see. Turn it in assignment. I'll share your assignment only. I'll see yours. Just give me a minute. Hmm. So are you able to see this? Are you able to see? Please speak because I have opened this तो मुझे messages नहीं दिख रहे तुम्हारे. I could not see your messages. I can only hear you.
Yes, ma'am, I can see it.
Okay. So can you recall this assignment? So here these are your hyperparameters. Can you see this?
We
Batch
can
size.
only see the file explorer, ma'am.
You cannot see this file, the PDF file.
No, we only see the file explorer.
File Explorer. Oh, wow. How to do it? This one you are not able to see. How you will see this? Share. What should I share? Application.
You can, I think, like Ganesh sir did yesterday, you can share the PDF like you shared the slides. You
But
can
I cannot
upload the slide
PDF
PDF.
now. Okay, let me see why I'm not able to do this. I can share my whole screen, then you will see, right? So now are you able to see?
Yes, ma'am.
Yes.
So are you able to see the PDF?
Yes, ma'am.
ठीक है. So what are you seeing?
In
So
the
algorithm.
classifier script.
हाँ ये दिख रहा है, right? So if you can recall, this was the earlier MLP classifier that you made, and these are the hyperparameters. Okay, this early stopping, batch size you can see here. Okay, so now what you are trying to do through this MLP classifier is, earlier you did these experiments by hit and trial. So this was that when you set it to something value, when you set number of PC something, number of hidden neuron, and then you trained it so many times and then you got some accuracy. So this one is what you were doing it manually. But now through your random search, you would not be following this method now. What you would be doing is you would be applying this random search method, and then you would be getting certain set of these values which would be best for your experiment. Okay, so did you get it?
Yes, yes, ma'am.
Okay, because you need to understand आपको करना क्या है इस assignment में. That is very important to understand this. We are trying to search the hyperparameters, best configuration, Samrat, because that best parameter can only give us fetches best possible values. Earlier also you did that, but you did it manually. So I was here, and then so this was something we did earlier. Mostly it is adopted by researchers, students, and hobbies. So that's why I told you to search, go through various research papers, because this one is the most followed one. And normally in academic community, we need to adopt this method also, this method only. Okay. So now I'll talk a little bit about this grid search also. Okay, so let me show you first. Mm, okay, I'll show you the diagram also of grid search. This one is the diagram. First, see the diagram. Can you see this diagram? Okay, so just make an image of this diagram into your mind. This image, this is an image of a grid search. When you apply a grid search, and that too in a two-dimensional network. So you could see that this graph is plotted between the learning rate and the dropout rate. So that's why I told you that these two rates are very important. Learning rate is your rate of learning. Dropout rate is the rate at which you remove some layers. So that is dropout rate. And these are the machines available. So this one is processing this particular part, this is processing this one, this is processing this one, and in between there can be other. So let's first talk about this thing. I'll talk about this learning rate also in detail. So when we talk about the grid search, we talk about that there in a grid. Uh, Let me show you where's the diagram. Can you see this diagram? So this is the diagram for the grid search, and this one is for the random layout. Okay, so in a random layout you could see the parameters all randomly, but here in case of grid you could not see that particular thing. Okay, so I'll more talk about this one by one. First I need to tell you about this. Okay, so what we are saying that in a grid, for example, let's say there are also n dimensions. Okay, and when I'm talking about n dimensions, then because earlier one you could see only two dimensions. So for example, let's say there is a learning rate, there is a dropout rate, and there is a batch size. So these are the three hyperparameters. Okay, and let us say for that, for every possible value you define certain batch size. You give sometimes like batch size 4, you can give it 8, you can give it 16, 32, 64, 128, 256. It depends upon you what kind of modeling you are doing and what kind of values you are trying to put. Okay, and then because since you know, I gave you the searching mechanism. This one was the searching strategy, that how do you search up. So when we are trying to apply a grid search, we are trying to see that is searching for all the possible configurations, and we are waiting for the results which one are the best. Okay, so for example, you see that this C1 classifier gave with these value gave, this means that 0.1 is the learning rate, dropout rate is 0.3, and batch size is 4. Are you getting it? Okay, so this one is a C1 configuration. C1 means configuration 1. This one is the configuration 2. So if you could see, when we have set the value of C1 like learning rate as 0.1, dropout rate as 0.3, and batch size as 4, the accuracy was 92%. But somehow, if we change the value of dropout from 0.3 to 0.35, the accuracy of this configuration was 92.3. And this way we can find out all the possible configurations, and then we can have the best result. So this is something, by search you got these values. By search you got these values. And based on this, then you got some kind of accuracy when you trained your parameters and then you establish this accuracy. So this is what you are trying to do. Okay, in both the searches, if I would say random search also you are trying to do the same thing, in the grid search also you are trying to do the same thing. But in random search, your search is not fixed, it's randomly done, and in grid it's just way by way. Okay, so this one is clear, this slide is clear, let me know, this slide is this clear, is this okay? Only Bidwat, Praveen, बाकी लोग, Dilip, Chiranjeev, Subarna, Vivek. Is it clear? Okay. So this one is like you are okay. Now I talked about dropout rate. Okay. So first let me show you the. So this is the diagram, okay, of a neural networks, and these are your hidden layers. So this one is one layer, this is the second layer, this is the third layer. Okay, so what we are trying to do in dropout is, if you can see this cross is representing the dropout, means removing. Okay, so basically this dropout is a technique, okay, and a technique of regularization. So first, ये क्योंकि I have already told you, पहले मुझे ये बताओ regularization क्या होता है? Let me know where we studied this regularization. Regularization बोल दूं या generalization बोलूं? Regularization or generalization? Please answer. You can speak on the microphone, there's no problem. Please let me know that what is generalization. बताओ भाई. While studying overfitting, okay, that is okay, but what it is? Okay. Overfitting क्या है? What is overfitting? What is overfitting? Any answers? Okay, all of you are right. Okay, so now we are saying that this dropout is actually a regularization technique. When I'm talking about regularization, I mean generalization only. Okay, and generalization, if you can recall when we studied our backpropagation algorithm, there we talked about overfitting. Okay, and overfitting is when we are training the model, and when we train it so well that when it is not able to classify, misclassify जिसे बोल रहे हैं, okay, because it does not follow the same pattern as our training data. So that is your overfitting. So when we are doing the generalization, or we can say regularization, whatever term you use, this is the dropout parameter, hyperparameter, and normally we say that the value ranging between 20% to 50%. Okay, so when we say that it is 20%, we say that 20% is a good value to keep. Okay, you can set the value between 20% to 50%, because when you will set very low value, then it will have very minimum effect, and when you will have put high value, then your network will again underlearn means that it is not learning well. Again, there is problem of overfitting, because when you are doing overfitting, there comes two problems. One is there can be the problem of overfitting, there can be the problem of underfitting. So these two problems can arise. So that's why you are keeping this dropout value between 20% to 50%. Normally we say that according to the various models being made, they say that 20% is a good point to start with. Okay, and when you are using a bigger network, when you are using a larger network, so you will get and it is said that you are most likely to get better performance when your dropout is used on a larger network. That means when you have a larger network, at that time your this dropout value will give you a better performance, and that's why your model will be a good model. Okay, in case of large models. In case of small models, this won't have that much effect. So this one you could see, this one is the dropout rate, representing the dropout rate, and then comes your learning rate. Okay, so on the right you could see a diagram of gradient descent. Can you all tell me now, can you recall and tell me what is gradient descent? हमने पढ़ा था इसीलिए पूछ रही हूँ. That's why I'm asking, what is gradient descent? Anyone else? Using slope derivatives. Okay. What else? Chiranjeevi, Narayan, Navneesh, Praveen, Astha. If you can recall, I told you when I started this gradient descent and we studied this in quite detail, I told you that gradient descent is gradually reducing the errors. Okay, this means the descending. Descent means descending gradually. And what we mean? Errors. Okay, so that means we are trying to reduce the errors gradually. That is known as gradient descent. Okay, so this is an example where you could see on the right, this one is showing a big learning rate, and this is an example showing small learning rate. So if you can see, this has learning rate very small. Earlier it was here, then after learning it was here, after learning here, here. Then this learning rate is very small. Very slowly it is trying to learn. This network is trying to run very slowly. And if you could see this one has a large learning rate. So this one you can say this one has a low learning rate or a small learning rate. And if you have a small or a low learning rate, then you will have a slow learning process. Okay, and if you are having a large learning rate, then definitely you will have large learning process. Okay, and when I am talking about learning rate at this time, that means I am talking about what I am talking about when I am talking about learning rate. I am talking about this thing, that how we are training the network. See here. So when I told you about learning rate, at that time I told about this. That means we are talking about how we are training the network. Because for example, how we are training the students, that is the learning rate for the student. And every student has his or her learning rate. Okay, so this is the learning rate. So lower learning rate means lower training, higher learning rate means higher training. जितनी ज्यादा ट्रेनिंग होगी उतना अच्छा लर्निंग रेट होगा, जितनी कम ट्रेनिंग होगी उतना बुरा लर्निंग रेट होगा. ओके, तो ये आप यू कुड सी ये स्लोली कन्वर्ज हो रहा है. दिस इज कन्वर्जिंग वेरी स्लोली. Okay, whereas this one the rate is higher but it's not converging. Okay, so this one is your learning rate. Okay, so mini batch size we already discussed about that in grid search also, but by default a good batch size is this much, 32. Okay, but you can try for 64, 128, 256 and so on. But the best one is 32. Again the dropout, in dropout also the best one is 20%. So this is again the diagram between the learning rate and the dropout. So you could see that. Okay, and one thing that you would see here that doesn't work in the grid search is, you can call it the same thing as your curse of dimensionality. So Okay, can you recall this curse of dimensionality? Can you recall that diagram I showed you on about principal component analysis of one-dimensional, 2D dimensional, and then three-dimensional, where I told you to drop a coin in just a line, you will get it. When I told you to drop it across two dimension, it will be again difficult. And then the three dimension, it will be more difficult to find that coin. If I say you drop it in the football ground, a big football ground having spectators, there it will be very much difficult because that is there the 3D dimension is taking place. So this is the problem with the grid search also, and that's why we call that when we apply grid search, the grid search has this problem of curse of dimensionality. That means you try to add more and more dimensions into your grid search. Okay, the more search will explode. There will be more search exploded against your time complexity, and that is normally an exponential factor. And hello, hello. Okay, close this. कौन सुना रहा है ये गाने? Who is somebody singing? Okay, ये चिरंजीवी हो सकता है, चिरंजीवी है ये. Okay, so one problem is there with the grid search. You can call it as a disadvantage of your grid search, or you can say this is the major problem with the grid search approach. Okay, and another thing is that for this grid search, you require more computational resources as compared to your random search. So for grid search, you require more computational resources as compared to your random search. So these are the two things which makes the random choice much more better than your grid search. Okay, so it is said that when you are having less dimension, or you can say you are having dimension up till 4, you can use this grid search, but then again it will not guarantee that what kind of best configuration you will find through your grid search, and hence this grid search is not preferred. Okay, so if it is not preferred, then what is preferred? The answer to this is the random search. In this case, does dimension signify number of parameters? Yes, 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 yes. So for here, you could see here because yes, you could see here also we talked about this n dimensions and n is equal to, yes, you are right. Yeah, yeah. So up till 3 or 4 dimension, this grid search will work, but after 4 dimension, this won't work for a large network. That's why this approach cannot be applied to a large network. Yes, 3 dimensions, but then it just showed up with the 2 dimensions. So now you can see, so when you are applying the grid search, this kind of code something you would be writing for your random search or grid search or whatever. So you could see the code is very small. So this is the grid search cross validation technique. So grid search CV, these are the estimators. These are different parameters you can see. You have already gone through this before. So CV, njobs, param grid, verbose, grid result, grid fit, and then you are trying to find out the result. So this is when you applied. Yes, yes, yes. This code is from the scikit. Yes, yes. You can use scikit. You can use scikit. Okay, you can use scikit. And then you could see here this example. Again, this is an example of grid search. You can see the model is created. Okay, after creating the model, we have defined certain range. After defining a range, there's a grid that has been prepared, and then this one is the grid search in action. So this is the main code for your grid search. Okay, so then you are trying to find out the best grid search score. You are trying to find out the mean test score, then the standard test score, and all this, and then trying to find out the best value for the model. So this is an example of the grid search. Yes, so if you can see here this diagram, okay, so this diagram is where we are talking about this grid search. So if you can see, this is just line by line, point by point, and after this point, see here, we started from here 1 2 3 4 5 6 7 8 9, and then from here it will move to this, then again this searching, then searching this way, then searching along this horizontal, then it will reach over here, searching the points again over here, then moving further, then searching, moving, then searching. So this is the process that it follows. Okay, so grid search is trying to find out the parameters this way. Okay, and in this case, who will be the winner? We can say the model which is having the best accuracy or the highest accuracy, that particular model is followed. So this is again an example. So let me give you an example. For example, let's say, okay, so this is an example being performed over the hyperparameter. Okay, and what is this support vector machine? This is a classifier. Okay, support vector machine is a classifier. So if you can see here, this is the value of C. Okay, and classifier C configuration, this is 1.0, then 2.0, 5.0, 10.0. So 1, 2, 3, 4. And then this is the value of kernel function. So there can be a radial basis function this is known as RBF. Then this is a linear function. This is a poly function. Okay. So what happens in a grid search, you can see here. This is all the value of C is set to 1. So it will search this way. So all the value, first it will take this value 1.0, and then with this kernel it will search, then it search with this value, then it will search with this value. After this it will move to this one 2.0, and then again you see this, the value of set is set to this, and then again this whole, then further this 5, then again, then further C is equal to 10. So this is the way the grid search works. Why I'm saying this? Because see here, because it works is this way only. Okay, and here you see this is your one model, this is your first model, this is your second, third, and the fourth one is not written here with value 10. And then the one with the best accuracy out of this 4 is selected. Okay, did you get this? Okay, so again, Bidwat asked me the scikit. Yes, scikit is a very good library that you can use with grid search, with random search, because scikit helps you in simplifying your process. Okay, and because as I already told you that optimization is an costly process in terms of computing, in terms of your power, in terms of your time. Okay, if you could see here also, again, if you have, this is just for the 4 parameters. So for example, like if you have different parameter values for these 4 parameters, so there will be different trials of cross validation. Okay, so that means that you are using the 10-fold cross validation method over here. So that's why you can use the scikit library. And for random search, you see here. Can you see this diagram? Can you see this one? See here, in random search, it can go anywhere. There's nothing like that it should go in this order only. That was happening in your grid search. But in random search, it can move in any form, any way. So that's why the searching is very easy. If you're here, you found the point over here, you can move up till here. From here, you can further come to this point. Any way you can move, and that is the advantage of your random search over grid search. So see the difference. I'm showing you both the diagrams. Do we need to provide the predefined list in random search as well? Predefined list means, Bidwat? Not clear, it's not clear. Can you a little bit more? Make it a little bit more clear to me. Okay, so now please let me know that where the chances of finding your optimal parameters are high. Here or here? Please reply. This one, which is your grid search. Here the chances of finding the optimal parameters are or here. So where do you think the chances of optimal parameters are finding high? Please reply. बाकी लोग सो रहे हैं क्या? विद्वत, चिरंजीवी, नारायण, प्रवीण, राकेश, सलोन, सम्राट, उत्सव, विवेक. विवेक, are you random search? Okay. What about others? Random. Okay. 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 So you could see here in random search, you have more chances of finding out the optimal hyperparameters, since in hyperparameters, in random search, it has the ability and it does not assume that it will only have the best parameters in this particular line. Okay, so it's the how the random search work. It's assumed that every hyperparameter is important, equally important, and that's why it takes the combination of every parameter into account when it is applying the iteration. That is the reason. So this you can see, this is a graph plotted between the important and not important parameter. So you can see here. See, this is number of points lying above. So if you see here, this in grid, it has only given you 3 parameters. क्यों? क्योंकि उसने इसमें से he searched one, इसमें से एक ढूंढ के दे दिया, इसमें से एक ढूंढ के दे दिया. So just 3. But in random, you can have many points, many important points. Okay. So at last, this is said that don't use grid search if your searching space contains more than 3 to 4 dimension. Instead, use random search, which provides a really good baseline for each searching task. Okay, so this is you can see again the similar code, same building the model, then specifying the parameters and all, and then here you can see this is the randomized search code. So आपको भी इसी तरीके का कोई code you have to prepare the code, certain code like this. You have to use this. So this is your task actually. It's not a bigger task. The second assessment is not that much. So you have to apply certain random search method. Okay. And now I come to the question of Vidwat. Vidwat says that do we need to provide the predefined list in random search? 10 to 100. Learning rate is equal to 0.2. No, you would not be required because you will get the best model from the prediction. Okay, because that is what you are trying to do, and then so this is all. So your because random search is very much required. Grid search, you are required to understand all these kind of searches so that you can start with your assessment. So now I hope that your second assignment is clear. Now it is clear, your second assignment. Okay, and another thing, you will be seeing that requirement form. Can you see that requirement form? I've posted in your Braille announcement. So all those students who think that they have got B, they deserves, for example, let's say A. So they need to fill that form, and all those students who think that they deserve to be to get A plus, and they got A. So they all of those students need to fill it. Okay, got it or not? Okay, so like I tell. Okay, you have submitted. So you like Samrat, Bidwat, you should submit for A plus. Okay, like you have 70s, so you should say for like you wanted A plus for that. And those who are having B, they can go for A for writing over there. Okay? Okay, good. Okay, so that is all. Your date is 12 June. You know the date, right? Another thing I would like to say that normally in your AI there's not much left now, because now only you have to apply these algorithm and write your assignment. Since like this one is your according to the university week 10th, and they have given the syllabus up till week 10 only. Okay, but still next class also I'll take on Friday, and then after that you need to continue to your assignment only. So I'll take classes on Friday about again search in AI. Then I'll talk about A star search if some students want to apply, or some wants to apply Bayesian. Then we'll talk about that. But I don't think now much of this we require. And I don't know about system development process. Okay, you can. Okay, you can again submit it. You can submit it again. There's no problem with that. I'll open the link. You submit it again, okay? There's no problem. Just submit it after. Okay? So thank you everyone. Thank you dear students for coming to the class. I know it's very difficult for you too because of internet and all, but you have to keep the pace. You have to keep working. Also, you need to focus because we need to